Hello. Hello, everyone. Hello, everyone. Hope you are doing great in this cold weather. I'm Kenni Konate, a data scientist and certified project manager. Actually, today we are going to speak about deep learning using TensorFlow and Keras as libraries. So firstly, we will introduce or have a little introduction about deep learning. So what is deep learning? Deep learning is a subset of machine learning that allows computers to learn directly from the raw data without the need for human engineered features. So the facility that deep learning gives us is that there is no need to feature engineering with deep learning. Deep learning is based on artificial neural network to solve complex problems such as recognizing images, classifications, understanding speech, and generating text. So as deep learning is based on artificial neural networks, so what is artificial neural networks? Artificial neural networks is a mathematical model that tries to simulate the structure and functionalities of biological neural networks. So we are going to see a picture. Let me a little bit speak about neuron. It's a simulation of the neuron in our brain. So in brief, that is. Yeah. How they work, the fundamental processing element of a neural network is a neuron. This building block of human awareness encompasses a few general capabilities. So basically, a biological neuron receives inputs, processes them, and give a result. So the same that we have in artificial neural networks. So as you see here as a picture of a simple neuron, you see the dendrites in the above. So accept inputs. With soma, process the inputs. With axon, turn the processed inputs into outputs. And with synapse, you have the electrochemical contact between neurons. So in artificial neural networks also, we have inputs. We have functional activation functions like softmax function. And we process the inputs, and as a result, we have the outputs. So there is simulation between them. That's actually what we are what we want to explain here. Also, we have with deep learning a new and a good term, which is transfer learning. Transfer learning is the improvement of learning in a new task through the transfer of knowledge from a related task that has already been learned. So as you hear, there is transfer and learning. So we have learned things, and the knowledge that we have learned, we transfer them. Because if you have an experience in something, you have the more the high probability or the more probability to master these things than someone who hasn't any experience with it. So here in transfer learning, it's the same. Models are trained on data sets, like big data sets. So we have knowledge learned in this training, and you can get this model to train low or less quantity of data, but to have a high performance and a high accuracy of other models. The model that we are going to use here as a transfer learning model is the Xception model, which is a deep convolutional neural network architecture inspired by Xception, where Xception models have been replaced with depth-wise separable convolutions. So here you hear the Xception model. Yeah, we have Xception model, Xception v3 model, and Xception model is a new model that is based on these models. So is more deep model, we can say. Of course, we will have a high accuracy when it's compared to the other models that I mentioned before as Xception and Xception v3. As also we can say that this model is created by Francois Cholet, and it was published on one of the known conference, ICVPR conference, CVPR conference, and it was on like in 2015, 2017, yeah. Here we can see the architecture of this model. So we have entry flow, middle flow, and the exit flow. So of course, in the references, by the end of this presentation, you can see the references. So from those articles, you can like search about them and get deep dive more in these concepts, these terms, and have more knowledge about like Xception model architecture and what is it. Of course, with every model, we have evaluation metrics. So what's the importance of it? To evaluate the performance of our model. So what is evaluation metrics? Performance indicators are very useful when the aim is to evaluate and compare different classification models or machine learning techniques. Those metrics turn out to be useful at different stages of the development process. Of course, for comparing the performance of two different models or analyzing the behavior of the same model by turning different parameters. So it's the usage of the evaluation metrics. We have cites some of the evaluation metrics, especially those for classification. So we have confusion matrix. The confusion matrix is a cross table that records the number of occurrences between two raters, the true actual classification, the true or actual, you can use true classification or actual classification, and the predicted classification. So as you see in the table here, in the gray color, the predicted and the actual. So we have the predicted classification and the actual real classification. As you see here, we have a positive, negative for the predicted and also for the positive, negative for the actual. Here we have also precision. So there is a method of calculation for precision. It's the fraction of true positive elements divided by the total number of positively predicted. So we have true positive divided by true positive plus false positive. Recall also is one of the evaluation metrics, which is the fraction of true positive divided by true positive plus false negative. Another and the most popular metric, which is accuracy. So, like maybe in every paper, or it's an obligatory, or can say it's a must to have, a must to do, that we use the accuracy in every paper, in every scientific paper that's related to classification, deep learning, image classification, etc. So the accuracy is the fraction of true positive plus true negative, so the total, divided by true positive plus true negative plus false positive plus false negative. So all the true divided by the total. So that we can say, as you see here, true positive, true negative. Yeah. Yeah. Here there is a little introduction about TensorFlow and Keras, the libraries we are using during this presentation. So TensorFlow, and you can search about it. There is an official website for it. Is also an open source end-to-end platform for machine learning developed by Google. And it's enable researchers and developers to build and deploy machine learning powered applications. Keras also is a high-level API designed for building and training neural networks. So you can say that TensorFlow is the back end, Keras is the front end in brief. The dataset that we are going to use here for the practice that we are going to do is the UIC Food 100, but the modified version of this dataset, which is from the University of Electro Communications in Tokyo. This version is perfectly balanced to eliminate bias, containing exactly 100 images per class. So here the real-world photos, so focusing primarily on Japanese cuisine, so you can see sushi images, ramen tempura images. Kaggle is a platform that we are going to use to train our model. I have already introduced Kaggle in a previous video, so here we are going to practice. Here we can see the references that I have used for this presentation. So here, at least in the list part, you can see TensorFlow and Keras, the link to their websites, so you can get more information about them. And of course, here are the scientific paper, the articles that I have read to get more information about deep learning. So you can read them to get deep in the concepts of deep learning. You can read, of course, more on Google Scholar and other websites, and other resources. Let's now start the practice part. So we can go to Kaggle to train our model. Okay, actually, we are on Kaggle now. So here is my work. The model that we are going to use is the Xception model. Let me see. Those notebooks are published, so you can use them anytime you want, of course. This one is published, so it's not the one that we will run it because it's already published. But let's do the practicing on another one. Here. Okay. So let me see the historic. Yeah. Actually, this one is based on the same notebook. So I download that notebooks, and from here, of course, import notebook. I just import it from here. Okay, so let's run it. Firstly, it starts from importing the libraries. As you see, what we focus on is here is the evaluation metrics, actually, as a result in the model that we are using here, which is the Xception model. I hope there is no error. So to not deal with it during but no problem to deal with it also. Okay. To run it without any problem. And this also, I actually copy the directory path and paste it here. That's the only thing that I have done in this step. Let's run the other step. Hopefully, wow, not found error. As here you can see all classes that we have in this dataset. Let's try to deal with this. Actually, we have error here. Still have it. Let's remove it and edit again. Okay. We still have it. Sometimes it happens. Let's actually delete the notebook. Or import it again. With dataset, I will actually add the dataset again and run it. Yeah, I'm going to the process so you can see how we can deal with all these steps. Hopefully there is no error. Let's and paste it here also. Then run it again. Actually, it was run it. Let's run it again. Normally, of course, if there is no, it's too weird. Don't have any problem here, so we have a problem here. Okay. Actually, we should not have any error, but if there is an error, okay, then to not take a lot of time, I will try it one more time. Let's wait until the data is downloaded. Okay. Yeah. Let's see. Let's try. If we get an error. Yes. Clearly. Set the path. But we have already trained this model. We have the it persists, so let's have the other solution, which is to import it again. As the problem persists, so we will go from the trained one, which I have already trained. And as you see, it's the result here. Maybe there is some option. Actually, it's all run it. Actually. Okay, firstly, we start with importing the libraries, as you see here. Then the path of the datasets. Here it shows all the classes that we have in our dataset from 1 to 100. Here we enter to see the labels that we have for every image. And as you see here, we have 10,000 rows in 2 columns. Here we count the value of labels that we have. As you see, we have 100. Here we split the train dataset, so we have 70% for the training dataset. Here you see the usage of Keras. So we have TF as TensorFlow and Keras here. So here we get our models, which is Xception model. Of course, you can choose the other models like Xception, Xception V3, and all of them. Here we used the technique of data augmentation, as you see here. Here, the modeling. So our model is trained here. As you see, it's already trained on the ImageNet dataset. But here, we're fine-tuning it to use it on our dataset. The activation function that we have used here is softmax activation function. Train the model, then actually let's go to the result. Yeah, here is with the fit function. We fit the model, so the training is here. As you see, yeah, here we have the result of our model. So we said that we use many metrics, evaluation metrics like accuracy, F1 score, precision, recall. So the accuracy of our model is like about to 100%. The test accuracy, because this one is the one is counted, which is the test accuracy, and not the training one. Here we can see the confusion matrix, as you see, because we have a lot of multi-class classification. So you see, this is diagonal. Here we have the training and the validation accuracy as plotting. We plotted here. Yeah, we can see an overfitting, of course, and we know that there is a lot of methods to deal with the overfitting. So maybe later we can check another video to speak about it. As a resume, here you see the precision recall F1 score as evaluation metrics for all the classes that we have from 1 to 100. So the value of everyone as calculated by the calculation methods that I have showed you. And in result, we have the accuracy of our model, which is 50%. Yeah, actually that's what I want to show you today. So thank you for listening. I hope that it gives you an idea about how to train the model, the deep learning models, transfer learning, and all these terms. Thank you for watching.